Hello everyone. Welcome to the class of E-Plan and Electrical Control Technology. In previous lessons, we have already learned about the control system design for passenger elevators, using contactors to control motor forward and reverse rotation for elevator movement. We know that besides passenger elevators, freight elevators are also widely used. What you see now is a freight elevator used for transporting materials in tall buildings under construction. Unlike passenger elevators, freight elevators have a larger carrying capacity. Therefore, in this lesson, we will design an energy-efficient control method for freight elevators, which is the star-delta starting method, to reduce energy consumption during operation. Now let's learn how to use the star-delta starting method to control the upward and downward movement of the freight elevator. First, let's take a look at the process requirements of the control system for the freight elevator in this design. The traction machine is an 11 kilowatt 3-phase induction motor using star-delta starting. The system requires necessary protection such as short circuit, overload, undervoltage, interlocking, etc. Next, let's analyze the working principle of the freight elevator control system and draw the electrical schematic diagram as shown in the figure. Star-delta starting for a 3-phase induction motor means that when the motor starts, the stator winding is connected in a star configuration to reduce the starting voltage and current. After the motor starts, the stator winding is switched to a delta configuration for full voltage operation. In this circuit, KM1 and KM2 control star-delta starting, while KM1 and KM3 control delta operation. Now let's analyze the starting method of the 3-phase induction motor. Pressing the Start button, SB2, the coil of contactor KM1 is energized. KM1 main contact closes, forming an autolocking. At the same time, contactor KM2 is energized. KM2 main contact closes, and the motor starts in a star configuration. Meanwhile, the time relay KT coil is energized. The countdown begins. When the time is up, KT normally closed contact opens and normally open contact closes. KM2 coil is de-energized first, and then KM3 coil is energized, and the motor operates in a delta configuration. Press the stop button SB1 and the motor stops running. Let's take a look at the circuit protection section again, as shown in the diagram. The circuit also has 4 types of protection: short circuit protection, overload protection, interlock protection, and zero voltage protection. The Level 3 fuse achieves short circuit protection for the main circuit, and the Level 2 fuse achieves short circuit protection for the control circuit. The Level 3 thermal relay realizes overload protection of the main circuit, and the Level 1 thermal relay realizes overload protection of the control circuit. 3 contactor coils provide zero voltage protection. The normally closed auxiliary contacts of contactors KM2 and KM3 are connected in series with each other's coils to achieve interlock protection, ensuring the safety performance of the freight elevator and preventing short circuits. Finally, let's take a look at the equipment selection for the freight elevator. As shown in the table below, the equipment mainly includes miniature circuit breakers, fuses, contactors, button switches, and thermal relays. Now let's make selections one by one. Miniature circuit breaker. we choose a 6 square millimeter multi-strand copper core cord with a current carrying capacity of 32 amperes. For the circuit breaker, we choose Chintz DZ47-60 3P D25 amperes, or alternatively NXBE-63 3P D25 amperes. Fuse selection. Selection of fuse element. For the main circuit, the fuse element selection is R228-63 40 amperes. For the control circuit, the fuse element selection is RT28-63 4 amperes. Selection of fuse. For the main circuit, the fuse holder selection is RT28-63X base 3P. For the control circuit, the fuse holder selection is RT28N-32X base 2P. Selection of contactor. For the main circuit, we choose CJX2-2510 380 volt contactors. For contactor auxiliary contacts, the selection is F4-22. Selection of button switch. For push-button switches, we choose Chint NP2 series switches with green and black colors. Thermal relay selection. For thermal relays, we select the JR36-20 model. Everyone, in this lesson, we focused on the energy-saving control design for the up and down movement of freight elevators, including process requirements, principle analysis, and equipment selection. Through the design schemes of control systems for both passenger and freight elevators, we can find that when designing a system, one should design electrical schematic diagrams according to the working principles of the control process and process requirements. And finally, make equipment selections based on practical experience. This approach results in clear thinking and well-defined objectives, making it easier for engineers to carry out projects. Have you got it, everyone? That concludes all the learning content for this lesson. See you in the next class.